Hey, good morning, everybody. Welcome to the Data Insights webinar. My name is Chelsea Hogard. I'm the engineering team leader. Sorry about the delay there. We were working through some technical difficulties. So hopefully you can hear and see me okay. Couple things about the platform that we're on. If you want to make the presenter larger or the presentation larger, you can take those windows and move them around and adjust them as you'd like. We also have a Q&A, so feel free to ask questions throughout the webinar. So I'm going to start by talking a little bit about decarbonization and how that relates to process heat. We know that process heating is very essential for a lot of industries, producing a lot of the products that we use in our day-to-day lives: steel, cement, paper, food, etc. And traditionally, this heating is done through fossil fuels. Even though this is a less efficient heat source, it has traditionally been more cost-effective. But now, with the change in policies over the last several years, the government mandates, as well as other factors, have started to push companies to think about this differently. They're seeking greener alternatives, including electrification. So we're seeing a shift in these processes. So when we talk about decarbonization, there's a lot of different ways that companies are doing that today. Electrification does make up about 20% of those initiatives. So it's a large portion of the decarbonization efforts that are happening today. It's happening across many different industries, including oil and gas, chemical, iron and steel production, food and beverage, mining and quarrying, and renewable fuels. And we're seeing a shift to electrification among a number of different process types, just to name a few: heat exchangers, environmental chambers, furnaces, and drying or curing ovens. So despite the fact that fossil fuels have traditionally been used, there are quite a few advantages to using electric heaters and switching to this new technology. One is that we can use cleaner and renewable electricity. A lot of this electricity is becoming now from greener sources, so contributing to the overall decarbonization efforts across the globe. We do see, though, improved temperature control with these systems. You're going to see less thermal lag, additional fossil fuels. So with companies looking at updating their fossil fuel heaters to electric, we recommend taking a systematic approach to this change. And there's a lot of reasons to do this. So when I say a systematic approach, what I mean is considering the full thermal loop, the full system, and choosing components that will play together to make sure that system is running smoothly. So obviously we have our heater, but that heat needs to be controlled by a temperature controller as well as a power controller. We also want to look at the data that is in the system, as well as what are our sensing points. And so all of these components together make up what we call the thermal loop. And so all of these should come into play as we're upgrading our systems to electric. The benefits of taking a systematic approach include improved temperature control and uniformity, increased energy efficiency, maximized system reliability. It helps us ensure traceability for compliance, maintaining safety of our people and our processes, facilitating ease of use when the components are all playing well together, and then getting real-time information on performance. So as we're upgrading these systems, there's a lot of things that you're likely considering. So electric heaters have really been in the industry for a very, very long time. But to many of our customers who are electrifying, this is a totally new system for them. So Understandably, there's a lot of questions that come along with that, such as what will the reliability of the new heater look like? A lot of times these heaters are going into processes that are very critical to have high levels of uptime. Our customers want to know, how do I know when maintenance is needed? How do I perform the maintenance on the heater and the control panel? How do I ensure the uptime of the system? And then, of course, what are the operating costs associated with this system? And so as you're looking at a new heater system, all of these things should be considered, and the solution that you select should be able to help address these challenges. So we're going to go to a poll question. So everyone should see a poll question on their screen now. I'll give you a few minutes to answer that. So what is most important with respect to your transition to electric process heat? So if you're someone who is making that transition, let us know what is most important to you. Maybe you're in a position where you are working with customers to electrify their processes. So maybe you can answer this question in the context of what you're hearing from your customers. Okay, let's take a look at our response. Okay, so we had, looks like most of our participants said total cost of ownership was most important, followed by reliability. I think that definitely makes sense. I know that I've heard quite a bit about reliability. A lot of our customers are concerned about that. Just changing to a new system brings new challenges. So we're definitely looking at that. Okay. So I'd like to talk a little bit about what Watlow is doing to address some of these challenges, and more specifically, how we're using data to do it. So we see data as a really important piece of the puzzle in order to improve uptime, improve yield, reduce costs of the system. And really what we're trying to do through, we have this data insights package that goes along with our Watt Connect large and extra large panels. And this provides a solution to integrate the data and provide expert analysis you can use to optimize your process and really maximize the return on your investment in the process of electrification. So I wanted to share some more specifics of what we're looking at, what we're doing with the data. So there's plenty of analysis that we can do with the data that we're gathering from these electric thermal systems. So this is just a few. So one of them being power and temperature controller health. So making sure that the components of the system are healthy. There's no alarms or anything on the system that might prevent them from working properly. Also making sure that the PID control is tuned properly and everything is running smoothly. Environmental controls within the panel. A big cause of panel downtime is due to overheating. This causes component failures, and so making the conditioner properly on the panel, or in the case where we're trying to make sure the panel isn't getting too cold, space heaters should be running properly. And so having access to the data allows us to monitor the environment of the panel so that all the components can run properly, maintain that uptime. Isolated monitoring of field wiring terminals. So this one actually does require additional hardware to monitor. We have a component that will optically separate the sensing points from the controller, so we can actually put sensing points directly on the terminals of the SCR. The main reason to monitor this is that another big cause of panel downtime is terminals not being torqued down correctly. This is regular maintenance that needs to occur on the panel, and if it's not torqued down properly, you're going to have hot spots, so that can cause the SCR to overheat. So by actually monitoring the terminals directly, we can not only make sure that the terminals are torqued down properly, but also if you even need to extend that maintenance cycle. So, if we recommend that the terminals need to be torqued down, I believe it's every 6 months or so, we might be monitoring those temperatures and say, actually your temperatures look good, no need to. I see a lot of customers that have really good access to the real-time data of their system. They know what's up and running. They know if something's wrong. They have alarms. And typically they are storing this data into a historian, but maybe not necessarily using or looking at the data from the historian. And so what we are looking at is how does the data from the system today compare to, say, 6 months ago? And drifts in some of those variables over time can indicate that there might be a problem. And then lastly, failed element detection. So of course, elements in the bundle do have the potential to fail from time to time. And so being able to detect when that happens can allow you to, switch to the spare elements in the bundle, plan that maintenance in advance, and then pre-order replacement elements if applicable. Okay, so it looks like we have a question from the audience. So is the maintenance leader able to view this in real time through the app or a computer? So the way that we are handling this now is we are actually delivering reports to the customer. So there is not real-time access to information, but that is something that we're looking at moving towards is more near real-time information. Thanks for the question. Just to circle back to some of the benefits of data analysis on thermal systems. So having data-driven utilization of equipment, understanding how you're utilizing that equipment and optimizing those schedules. Recording variation between cycles will allow you to do proactive intervention. You can correlate the thermal profile to plant metrics, capture process drift with impacts on energy consumption. And even just tracking the energy consumption is important to people. Optimizing your timeline for preventive maintenance and system checks, and then improving your reliability and overall uptime of the system. I see a question, can the failed element detection system predict a future element failure, or does it just detect when an element failure has happened? So at this point, we can only just detect. We are not able to predict. We're still looking into that. And more specifically, on what time scale can we predict? If we can predict it 10 seconds before it happens, that's probably not enough time. And so we are working on algorithms to be able to predict further in advance so that our customers can be proactive. Okay, we have another poll question for the audience. So how much data are you collecting from your heating processes today? So maybe you're not collecting any data right now. It might be minimum. I have seen a lot of customers that are only collecting process temperature or a limit status. And then on the other end of the spectrum, we might be collecting all data from the panel that's available, including installed sensors. I think many of our customers might have quite a bit of data, but maybe not quite all. So they might be somewhere in between. All right. So we have definitely a wide range here, it looks like. Looks like most people are collecting either the minimum data or somewhere in between, which I think this is about what I expected. One thing I do want to note is that I think is important about the data insights package is that allowing us to take a look at some of these more detailed pieces of data allows you to focus on your process. So where traditionally many customers are only looking at process temperature and limit status, that might truly be sufficient for making sure that your process is up and running. So if we can offload some of that work, that would be ideal for a lot of customer situations. Okay, we have one more poll question. So this is about plant data in general, heating or non-heating processes. So how are you using analysis of historical plant data to inform your process? So maybe it just goes to the historian, you're not looking at it at all. Perhaps you're using it just in moments of troubleshooting. Maybe you're using it to inform standard procedures, or maybe you're a little bit more advanced and enabling predictive maintenance. All right, let's check out the responses. So it looks like a lot of people are not using their historical plant data at all. A lot of us are using it for troubleshooting. That's pretty typical. Informing standard procedures, we actually have 20% that are enabling predictive maintenance, so way to go. And I actually have an interesting question in the Q&A. So how are predictive maintenance algorithms verified or validated? Are algorithms run against real systems which are allowed to fail in order to verify the predictions of the algorithms? I think you really hit the nail on the head with, yes, we do want to be able to test these algorithms on real systems. The data and the environment that we have in our lab here at Watlow is very different from what it looks like out in the field, which is why we don't have true predictive algorithms today, but we are working towards that. And again, we want to test these on systems that, eventually might have an issue come up or might fail. We certainly don't wish that on a customer. So, but we're looking for opportunities where we can test that. Okay. I wanted to share a few case studies. So we had a customer that was having an issue where they were actually experiencing reduced flow on their system, and consequently their element temperatures were spiking and they were tripping limits. The interesting thing about this situation is this was a test system, and so they had additional sensing points on the heater than they would have normally. And so with the improved system visibility, we found out that the customer was, hitting those limits where they might have been doing this the whole time and not even known it. So, back to kind of the thermal system and the design of the thermal system, those sensing points are really important. Being able to identify where the hotspots of the system are, which those hotspots really change in the system conditions, so it's very hard to predict. In this case, also the customer was using contactor control to switch power to the heater, which is a much longer response time than SCR control. So based on what we were seeing with the data, we were able to recommend that they switch to SCR control in future systems to avoid those high fluctuations in the sheet temperature. And avoiding those fluctuations can also definitely improve heater life, so extending that system reliability. So the customer is actually in the process right now of validating the SCR control on their system. And this is also going to, help improve their system overall, allow them to focus on maybe other higher value tasks in their system. And so the data collection here really helped us lead to a more optimized system that can result in improved heater reliability and process safety. Here's another example where we were collecting data from a customer system. In this case, the customer system I would describe as very dirty. There's a lot of contamination present at the customer site. And so those process conditions would often lead to sensor failures. And so if we have a sensor fail, in the case of a limit sensor, that could lead to an undetected over temperature condition. The process will keep heating, thinking that it's not approaching that limit point, when in reality it is. So that risks a failure of the batch, but then also can risk damage to the equipment. So this was a really interesting situation where we were actually able to detect it when the customer was in a planned downtime, and before they started running again. We saw fluctuations in the sensor that showed it was likely shorted at a point that was outside of the system, exposed to the ambient temperature. So you can see the dark blue line is where we saw that high fluctuation. The light blue line in the graph there would be a normal sensor. So we gave the customer a call, and they were actually able to switch. They had multiple sensors in the system. They were actually able to switch their control over to use a different process sensor. So they saved the scrap from the product, and then also avoided any damage to their equipment. Okay. This is the last case study I have, and then we'll head over to a couple of questions. So this was in a semiconductor in a subfab. So if you're not familiar with semiconductor processes, they have chemicals going through pipes. They would go through a pump and then to an abatement system. And a lot of times, so these lines are usually heated to prevent condensation on the inside of those pipes. A clogged pipe can lead to downtime, and the maintenance is quite costly, having to take apart the system, clean out the pipes, and then put it back together. And so we had a customer that was having issues with clogs in their system. So we went in and performed data collection on the system. We actually added some additional sensing points. So again, back to the idea of how we're designing our thermal loop, those sensing points are really important. In this case, they only had one single sensing point along, an entire, multiple foot long pipe. And it was being controlled off of one zone of control. And so while at that single sensing point, it was at the appropriate temperature, we found that the uniformity along that line, the heating system was poorly designed from previously. And so we were able to detect that there were cold spots along those lines that was leading to a clog. So we made changes to the system in order to optimize the thermal performance across the line. I believe in this case, we actually separated it into multiple zones of control and actually ended up reducing the maintenance interval. It was every 2 weeks. They were able to go every 12 weeks before cleaning the line. So the estimated savings in downtime and maintenance costs is around $5 million a year. So quite a big cost savings in this case for the customer, all because we were able to get the right data. Okay, I'm gonna head over to some questions, but I did want to share, so there's a QR code as well as a link there. You can scan to get some more information on the Data Insights package. If you are interested in learning more, you can also reach out to the representative that you normally work with through Watlow. So I really appreciate everybody's attendance today. Again, I apologize for the delayed start with some of the technical issues. Hopefully things went smoothly throughout the webinar. And if not, we'll make sure that the content is posted later for your review. So, okay. Let me take a look at some of the questions. Looks like Dennis answered a question. So can you use leakage current? Oops. Can you use leakage current to detect element failure? So Dennis said that leakage current is a good measure of product performance. Current leakage isn't necessarily used to detect failure, but pending failure. So yeah, absolutely. That does usually require additional hardware in the system. So, depending on if there's room in the panel, we can add that hardware to monitor leakage current. Okay. So I see a question, is data insights limited to Watt Connect control panels, or can it be applied to customers' processes? This is a great question. We have actually done retrofits on systems. We have like a little standalone box that we call it the sidecar box, so it can come alongside your system, and as long as the components can speak Modbus TCP, Modbus RTU, even OPC-UA, Ethernet IP, we can connect to it and collect that data. Okay, looks like there's another question. Can the Watlow systems work on gigawatts of input? I believe that means gigawatts of input electrical power with the plant operating at 500 degrees C. Hopefully Dennis will be able to answer that question. Interesting question, but we are looking at very large, megawatt size systems for sure. I'm not sure if we're addressing gigawatt quite yet. Dennis said, power does not matter. System works on all sizes. Okay. If we didn't get to your, oh, sorry, one more good question. Is the data insights software based on the cloud or on-premise? Great question. So this is cloud-based. So we collect the data, send it to the cloud. It is sent over cellular, so that helps avoid any vulnerabilities on the customer's network, helps keep it secure. And then those reports are shared typically on a monthly basis. All right, I think there might be a few more questions in the chat. So if we did not get to your question, or if you have any questions later on, feel free to post them and we'll try to get back to you with an answer to your question. So once again, thank you so much for attending today. I hope you all have a great rest of your day.